So we want to thank Tim and his crew from DX Engineering for partnering with us and helping us to keep this going. And I hope you have a good time today. So I'm going to introduce Tim. He's going to talk today about new Yagi from Justin Johnson, I believe. And so Tim, K3LR.
Thank you, Gerald, and thanks to all of you who have faith to come back here and change of venue, change of structure and everything, but I can promise you a very fun day here today. So I hope you get a lot out of this. There is actually 3 events going on today. There is an event over at MFJ Enterprises, which has Justin Johnson is over there. It is the 45th anniversary of MFJ, and so they have an outdoor cookout, and also HRO is having an event today as well. So there's a lot of things going on in amateur radio today, as there is every day. There is always something going on in the world's best hobby. But I want to talk about the loop-fed array Yagi that Justin G0KSC has been working on. And in the upper right-hand corner here, you can see this is 4 of the 6-element LFA3s, and in a really nice H-frame array. It includes the power splitters, and these booms are a little over 30 feet long for each one of these Yagis, but optimized in the H-frame, it has tremendous pattern for 6 meter EME. And so one of the things that I've learned about Justin is that he is a perfectionist, and he has been really tweaking the designs of these LFAs, and he certainly had a lot of things to overcome. When you come to the marketplace or anything in amateur radio and you say, hey, I got something that's new and revolutionary and it's different than what everybody has been using, you have a steep hill to climb, because many of us doubt it. We just say, no, that's snake oil, or it's not really real, but this is the real deal. And he has perfected this design, and I think he continues to work on it. But one of the things that is really impressive about this is the signal to noise ratio optimization, where he's honed in on tweaking the pattern to reduce noise. And we all know on 6 meters especially that local noise can be the death of an amateur radio station. And by being able to direct your signal, the received signals away from the noise areas can really make the difference. And here's, again, this is the 5-element LFAs and a nice H-frame and KD7 DCR. And so here, a few months ago, Justin and MFJ introduced a line of the LFA Yagis that will be built in Starkville, Mississippi. It's under the High Gain brand. So you can get Justin's designs manufactured here in the United States. And so it makes it very easy to get this technology. So in 2007, Justin introduced the concept of the LFA, and so he's been working for the last 10 years on this. And under these 3 premises, low noise, wideband, so that means holding patterns across many frequencies, and also keeping the VSWR as low as possible. And then the ultra-high efficiency, and we want to talk about that ultra-high efficiency. What's the difference there? Well, it's all about in the construction and minimizing losses. Anytime that you have mechanical issues that create electrical resistance, that can ruin efficiency. And so he's put a lot of effort into this feed system, which promotes it. It's a very simple feed system that keeps the efficiency high. And so in that feed system, where the matching is done, there is no heating. And that anytime you have heat, you have loss. Heat means you have resistance. Resistance means you have loss. And so He does say that there's no input power limit, but we all know, 1,500 watts is what we strive to run here in the United States. It is a direct 50 ohm feed, so the only thing you have to worry about when you do that direct 50 ohm feed is that you properly choke the coax feeds that are going on, so that the coax feeds are not part of the antenna system. That is critical to maintaining these low noise arrays. Because of the closed loop, that also lowers noise and chances for static problems. And it is grounded to the boom. Again, that is a measure to prevent static issues. The loop itself does assist with the high front to side ratio, which is a characteristic of this antenna. And the front to rear is exceptional on Justin's design compared to other Yagis. This is a rotating tower at W7EW in Oregon, and that's Lou Serre, and he's got the 6 of the 7-element LFA2s, so this was one generation before stacked up on this rotating tower. And you can imagine the signal and the gain off the front of this array. So here's some of the work that Justin has been doing on bending of the reflector. And actually he's introduced at Dayton 2 years ago the idea of bent elements. And remember, if you think about bent elements, think about the TV antennas. Think about TV antennas. They've had bent elements for years, and these guys know the advantage. Now, there are mechanical things to overcome, and that's what makes it hard to do in bands like 50 megahertz. But at the end of the day, the bent reflector in the LFA2 really did enhance the front to back ratio just by the slight bending of that. But again, if you're in a windy environment, things are moving around, that can be problematic too. So the LFA3 has got longer booms and careful placement of the elements. And the idea is, if it rains, that the antenna holds its specifications, whether it's wet or dry. And so this, because Justin couldn't be here today, and believe me, I tried to figure a way to fly him back and forth between Starkville and Austin today, but it just wasn't to be. And he wanted me to read this to you, that there were 2 parameters that he wanted to achieve when designing the loop-fed array. And the first was to produce a Yagi that was designed with signal to noise ratio as being the primary performance indicator. And in addition to being a Yagi, that it was unaffected by other objects, other antennas. We do a lot of sharing of our towers and masts with other antennas. And also that it would be usable regardless of the weather conditions, whether it was rain, snow, or ice. And in order for that to be achieved, the elements had to be closer together, had to couple more, resulting in short antenna to element ratios. And the LFA3, or the 3rd generation, is the result of many optimizations that Justin has gone through. And while gradually extending the boom periodically, and the result is a much longer, wider spaced Yagi that is stable, it is quiet, and it delivers best-in-class performance per foot of boom. And so there's a YouTube video, and I don't believe, Steve, are you in here? I don't think we're hooked up to the internet, but these slides, all the slide decks will be available on the 6meterbarbecue.com website, so that you can download these slides and you can go and play these things. But there's a couple of YouTube videos that really show the performance of the LFA Yagis, and there's some side-by-side, a typical Yagi compared with the LFA with CT1HZE, and it's really phenomenal when you see these things on these YouTube videos. And so this is a good thing to take a look. But like I said, probably next week, Terry, KDMNJ will make sure that all these slides get loaded up on the website so that you can download it and then you can click on these links. Or you can just put into your search in YouTube for the LFA Yagis or CT18ZE. So here's one of the high gain 4-element LFAs. So it's on a very manageable boom. If you don't have a lot of room, it can be put up on a mast by itself. And Justin is working close with High Gain to produce these LFA 3rd generation Yagis. And he's got them on 6'2", 222, and also on 70 centimeters. And on 6 meters, going all the way up to 8 elements. So that's a nice size boom and a lot of gain. And and here you can see some of the comparisons, the 4-element, 5-element, and 6-element, how long the booms are and what the gains are, and then what the front to back ratios are. They are available in stock from the high gain dealers. That includes DX Engineering. They're just ramping up production. So we don't have all the models.
So are those going to be the same stainless steel construction that he does overseas?
No. The construction that the high gain antennas use is the high gain method. Okay. So this is different than an Nove antenna. If you want an Nove antenna by G0KSC, you need to buy that in England and have it shipped over. If you want the performance of these models, but it comes out as the high gain construction. So the clam shells that high gain has used for years, that's what this is. So here's the 5-element high gain version. You can see the high gain elements there. There we go. See the high gain clamps right there. Here's of course the driven element, the loop, reflector, and then the series of directors here. So this is the 5-element Yagi. And of course that's on a 2-inch boom. So a lot of this stuff is stock pieces of high gain, whether it was 20, 15, or 10 meter antennas. So they're just reusing the same sorts of boom and element materials to make this. Okay. Here's the 7-element Yagi. And boy, does that look sharp. A 2-inch tapered wall boom, and this could make a fine system for a stack of 2 or an H-frame of 4. Certainly quite nice EME array for 6 meters.
Yeah.
Yes?
So with the high gain elements of boom clamps, the elements stop at the boom.
That's right.
And of course, all the in-off antennas are insulated.
That's right.
So how are they doing one side or the other with high gain?
Well, they're joint. I mean, the way that's done is that's a continuous. There's no insulator in there.
Oh.
There's no insulator in the high
These
gain.
elements are grounded.
That's right. All these elements are grounded. Dick.
Okay.
Yes. That's a good point because it is very different. As Steve questioned, the no way that these elements mount to the boom and everything is much different. But Justin assures me, and that's why they ran all these tests. Here this is one of the high gain facilities down in Starkville. They ran a lot of tests to make absolutely sure that the model tracked the construction. The high gain construction is not as easy to model because of that very issue, as Dick pointed out. So this is the long boom 8-element on test and working well. So, yes.
Has this design been confirmed on like a ground reflection antenna range?
I don't think so. I did not ask Justin if this was confirmed on a ground test range. I don't think that it has. I think what they did was they assembled it as per the model. They checked to make sure that the VSWR was exactly what the model said it would be. And then they did some front to back tests, rudimentary, but certainly nothing, you know, like a range.
No.
So,
You get one of those down at Georgia Tech.
right.
Or scientific plant, excuse me. That would be.
That would be great. We'll have to ask Justin if there's any plans to do something like that. That's a good idea. Yes?
It's too early to ask how discussions early in tennis compared to the high games, you know, game per element number, game per.
A little bit better. I think that the gain, we all know that gain is associated with boom length. And so per a given foot of boom, he's squeezed just about as much as you can. But the idea here in the third generation is more optimization and better pattern control. Now, if you don't have any further questions here, I have a bonus presentation. You know, everybody likes a bonus presentation, right? And so, because we have some time, I thought it might be interesting to talk about an upcoming DXpedition that I think all 6 meter EME guys are going to go crazy over, and that's the Bouvet DXpedition coming up in January. So I communicated with the Bouvet team yesterday, and I said, hey, I need some slides to kind of go over your 6 meter plans. Well, they sent me a nice slide deck. I got it this morning. It was 70 megabytes, 160 slides. So I pared that down a little bit. And let's see if we can bring that up here.
Did they advertise with just a 2 meter EME?
They're going to do 6 as well.
On that basis, works out $500.
So one of the things that this Bouvet team, what I've learned about both Gerald and Flex Radio and myself and my DX engineering team have been working very close with the Bouvet team on this project. And one of the things I know about the 20 guys going to Bouvet is it's all about focus. So let's go and talk about this a little bit. Whether it's 6 meters or whether it's the HF bands, this is the #2 most wanted country in the world. And it is one of the hardest places to go to. And this is a DXpedition that has been in the making for several years. It is a tremendous commitment and a tremendous risk of life to go here. And so let's talk a little bit about what's going on. Well, this isn't the team, but this is this DXpedition team is the dream team, and you got guys like W0GJ and K4UEE and K3LR going. It's really good. These guys, they are professional DXpeditioners. If anybody doubts for a second that they haven't tried to think about everything possible that could go on and go wrong in this DXpedition, but this is some of the stuff that they've done in the past, and they have an unbelievable process that they go through to make sure that they do everything as best they can, including what happens if somebody dies. You know, you don't want to think about that. You hope that it never happens, but what if? And they have really taken into account everything. So this is where they're going. The most desolate place on earth. They're going to Bouvet. And so let's talk about the operators. You've got to be able to get away from home, off work for 8 weeks. That's a commitment. Oh, you have to be able to come up with about $25,000, each one of the operators. About $20,000 of that goes to the DXpedition. The other $5,000 is you got to be able to fly down to Chile to get on a boat. And once you get down to Chile and you get on the boat, you got to go. The boat is going to traverse. The boat is going to traverse through Drake's Passage. You're going to be sick. So by the time you get to Bouvet, you might be feeling just a little bit better, but now you have to unload all this gear. and put it on a glacier where you're gonna be for 2 weeks. So you're gonna work about 18 hours a day. You're gonna work the first couple of days setting things up. You might not get much sleep. And you're just feeling good after 2 weeks on Bouvet. And what do you gotta do? Tear it all down. Get back on a boat, and then get sick again. Boy, that sounds like a fun way to spend $25,000. And guess what? If you're one of the 20 lucky guys here, you don't get to work Bouvet. How about that? So this is just an unbelievably difficult place to go. It is 95% covered by glacier. And be thinking about these slides when you hear these guys on the air next January. Now, this is where all the previous guys operated from, right here. Nobody's ever been up on top. And so you're going through a tremendous mountain to some very key areas for QSOs. So this has not been an easy QSO in the past. But these guys are going to go up, right up here. And so they're going to be up on the glacier itself, and that is going to make a world of difference. See, previous operations sitting down here. Here's where the 3Y0Z will go. And they're doing it with helicopters. Not one, but two. What happens if the first one breaks and there's a problem? Now you really got a problem. But in that manual that I talked about, they've also figured out how they would get off of here if they had to without a helicopter. But they're taking 2 helicopters on this ship, just because you gotta have a backup. So this is the antenna layout, and this is the EME area. We're also, because this has a 6 in it, we're gonna talk about the 160 antenna a little bit. And, oh, here is the 160 antenna under test. This was designed working together with EY8MM and DX Engineering. This is a 90-foot vertical that can be raised with the falling derrick. And so this is what will go to Bouvet. And this 90-foot vertical has 70 feet of aluminum tower, and then a top 20-foot stinger. And then it is also top-loaded with top-loading wires. This is the base of the vertical, and what you can see here, this is the falling derrick. It takes a 40-foot lever arm made out of 3-inch tubing. And notice the pull pins. When we assembled this in northeast Ohio for a test, we all wore mittens to make sure there's, you see the base insulators? This is the matching network that it takes to match it to 50 ohms. Here's the radial plate. We've cut radials for them. And this went so smooth and so easy, we said, let's build them another one. So, you know, they have 2 helicopters. They now have 2 of these 160-meter verticals. And, yes, John?
What the wind speed average is.
Well, the wind on a calm day is about 40 miles an hour. But so we didn't have that kind of wind when we put this up. Notice this is a hinge base too. This is a heavy hinge base, but typically the winds are going to be 60, 70 miles an hour. So it's, hey, look at this. This is K9CT, and Flex radio is the choice of the 3Y0Z DXpedition. And so Craig was in charge of testing everything. After it left here, went to Craig's. Craig made absolutely 100% sure that all the Flex radios were ready to go. And then they were shipped to Atlanta. And then the container is loaded in Atlanta and should ship here in the next couple of days down to Chile to get loaded on it. 300 storms a year. occur on Bouvet. So this is a bad place to go. There's no Hiltons, no Marriotts. This is a bad place to go. So our thinking with this 160-meter vertical was, if they have a bad storm and it gets wiped out, I don't want to read about, well, that DX Engineering vertical didn't stand up to 160-mile-an-hour winds. Of course it won't. But if they have a spare sitting on the boat, they can get back up and going. Now let's say that they hit a really nice time down there and they're not having trouble with wind and the vertical is playing great. So they go the first few nights and they work all the top level guys, right? Get them out of the way. They can bring the second vertical over and have a 2-element phased array. We've put together a dual vertical array for them that they can change. They have enough radials for 2, and they can actually put up a 2-element phased array and get about 3.5 dB more gain, which would make a difference for a lot of the second tier or the mid-level tier stations. So here's the helicopter that is part of the ship that's going out there, and that's how they get everything on the island and off the island. Here's the boat, and this is much different than the Braveheart. It's a much larger craft. They have a lot more room, and it is capable of having the 2 helicopters. $750,000. And that doesn't include the donations that Gerald's company and my company have made. This is just incredible what it costs to do this. This is really something. You see the 2 pieces here of the...
If you're a under budget, that's really bigger.
The radio equipment is on loan from Flex, and the antenna supports are on loan from DX Engineering. So this is an incredible commitment to provide all of us in this room with a new country. So the antennas, masts, and coax are coming from DX Engineering. The radios and amplifiers are coming from Flex. So as Flex and DX Engineering teamed up to help put this on today, we also teamed up to stepped up in a big way for this major DXpedition. So there are the Flex radios in their Pelican cases. And inside, each one of them, all the cables, everything is labeled, ready to go. Here they are up at K9CT in the test. So let's talk about EME. They actually set up the EME and down in Atlanta a few weeks ago, and everything worked. So they are good to go. And again, hopefully the wind does not just destroy this.
Are they gonna have any kind of internet connection? I doubt it.
They'll have a satellite phone connection to the internet, yes. They won't have real-time log uploads, but periodically they'll upload the log. So what this is here, this is there are 14 sets of these. This is falling derrick antenna support structures for 20, 17, 15, 12, and 10 meters. And so that's what this is. This is the masts that go into these custom designed holsters that we did at DX Engineering. And here we are testing. This is again, another falling derrick, testing the mast that is used to support all the monoband Yankees. The boom to mast connections on top of the masts. And this is definitely a mega DXpedition. It has a lot of moving parts, but they do have an experienced team. They have tons of equipment. They have a good plan. And they have to stay a long time if they're going to work enough guys to make this worthwhile. Because it's all about the investment of money versus the number of QSOs and QSL cards. It is incredible the amount of planning that's gone in, but we all know that preparation is the best way to ensure success. So, there's a little deal like this in the back of the room that talks about the most remote place on earth. And it's coming up here. They expect to be on the island the third week in January. It should be a very exciting time to be in ham radio. I think everybody will be buzzing about this. Everybody will be trying to work it. They will use some of the new digital technologies that John's going to talk about, FT8, and but they're going to try to do their very best. And of course, this is a challenging time in the sunspot cycle as well. So this is their official placard. And if you would like to help support them, they would certainly encourage your support. You can go to bouvetdx.org, and they're trying to do everything they can to make this a big-time success. So I thought it was very appropriate to talk about this DXpedition here, so this is your bonus slide presentation.